Thanks, Chris, for the introduction and the opportunity to speak here today. So, kind of a little bit different accent than Chris's lovely German accent there. But so I'm taking a different perspective here. What I want to be able to share with you is my perspective on blockchain from the business point of view that I'm in. And the core business I'm in, and have been for many years, is artificial intelligence. And I do believe that artificial intelligence and blockchain have to be intimately involved, right? Because you've got a smart contract, it's got to have some level of intelligence behind it. I'll have to take this manually. So just wanted to kind of talk a little bit about myself and a little bit of a joke here. This is where I grew up as a teenager. Does anyone know where that is? Oh, actually, not that place, but close to it, within a few miles away. But does anyone know where that place is? Speak up.
Scotland?
No. Anybody else? First giveaway? No. This is Bletchley Park. And it'll have some meaning in a second as I go into artificial intelligence a little bit more. This is a guy on a movie a little while ago that had a role playing a famous person in Bletchley Park. Does that make it a little bit more familiar now? Right. So, this is out of order, sorry. Yeah, no, that's good. It's not working, but that's okay. So Bletchley Park was where cryptography was used, right, to really interpret the German military maneuvers during World War II, and by breaking that code, enabled Britain and the Allies to win the war, with the help of the US, of course. And so I grew up within a bicycle ride of Bletchley Park, and so as a teenager, there was always a lot of mystique and mystery about what went on there during World War II. And that curiosity led me to study computer science very early on in the late 70s, when it wasn't that prevalent of a science out there. So went to Staffordshire University, which at the time was only the second university in Europe to offer computer science. Manchester had been the first one, which is where Turing went to, Alan Turing. But unfortunately, Staffordshire University was better known for the Staffordshire pit bull, right? And also, if you notice, below that is Wedgwood out of Staffordshire. So very famous things, not so famous for the university. Here, you can have that back. So, okay. Let's see. There we go. So on artificial intelligence, and why I want to bring this up is because it's taken a long time from when Alan Turing first talked about thinking machines in 1952, and the term artificial intelligence first being mentioned at Dartmouth University in 1956. It's taken a long time till the present time when it's really having some commercial benefit. And hopefully that length of time doesn't apply to blockchain, but it has taken a long time. Over the history, 1997 was when IBM came out with Deep Blue, which took on the chess champion, world champion at the time. What was his name again? Totally gone from my mind here. Yes, that's right, yeah. That was in 1997. In 2011, February, IBM launched Watson on Jeopardy. And that was really a game changer, because the game of Jeopardy is you don't know what the questions are, right? So it's very hard for a machine to listen to the question, interpret it, and come up with the answer. And then a few years ago, Google DeepMind won the game of Go. 18 months ago, the computer won the Texas Hold'em poker game. And then just recently, what's very interesting is we're talking about 6 months ago, I think last summer, Google's DeepMind and their product AlphaGo actually destroyed the existing artificial intelligence for playing chess and winning chess games by taking a totally different track. When the original chess championship was done, the computers were trained on the strategy and skills of the masters of the game of chess, humans, right? How do you map a human mind into the program? But last year, AlphaGo took a different approach with reinforced learning, where the computer only got the rules of the game, but no strategies, and played each other. The machines played each other millions and millions of times and came up with strategies which were winning. To the point that the chess masters looked at these strategies and they'd never seen them before. And these are ways that computer had thought which humans hadn't, and it was better. So quite enlightening last year when it happened. Wrong way again. Sorry about this clicker problem here. So I wanted to talk about blockchain and the hype versus reality, right? Because that's in the application that I'm using in the business I'm in, that's very relevant. So what I have on here is the hype cycle from Gartner in 2017, and you can see over here that in the peak of inflated expectations, we have blockchain just to the left of that line, and then a year later, it's almost to the right of that line, if you can see it there, right? Where at the same time, you get connected home, which was about the middle of this segment here, right? And at the same time, connected home comes all the way down here. So this is a typical cycle that technologies go through. And I'm not sure I agree with the connected home because I just installed it in my house about 4 weeks ago, and the bloody thing's still not working quite right? You expect Alexa to turn the lights on, and she does something else. It doesn't, I mean, I've got all the lights, the heating and everything that's now connected to these bridges where you can turn them on through voice commands, and it's still got a way to go. So with blockchain, the promise of blockchain is twofold, really. You've got the element that the banks, in trade finance, this is switching now to trade finance, my industry. So you've got the element of trust, which is provided by a third party, most in this case in trade finance, a beneficiary bank or an issuing bank. And then you've got that being replaced with technology providing the trust through cryptography. So that is a significant difference. But the velocity of how the success is going to progress, when you look at Bitcoin, right, it's what, 2009? When would you say blockchain actually started?
Blockchain started?
Yeah. With
the Bitcoin application in 2011, I'd say. Right?
Yeah, okay. Yeah, so it's at least about 10 years then, really, it's taken. And what I'm trying to figure out is, okay, what is the time frame for it to really take hold in my industry, which is trade finance? So I'll give you some examples of some blockchain, or actually distributed ledgers, which are out there. There's one which was started about 18 months ago called TradeLens. And this is between IBM and Maersk. Maersk is the biggest shipper of containers globally in the world. And they have put together their blockchain-based global trade on Hyperledger Fabric, Fabric being the IBM version of that. Maersk is a customer of ours, and I was talking with them last week, and this is a great opportunity for them and IBM, but it's creating a little bit of delay in adoption because the other shippers don't necessarily want to be within this consortium, very small consortium, Maersk and IBM, with a competitor. But it's certainly got a lot of potential, and it says in the write-up that I pulled from, 94 organizations are now in their program. And so that's good. I think what's important is how much of the transaction in the supply chain are actually being taken, processed by that. This is probably the biggest one in trade finance, the company Consortium R3, which has their product Corda. And there's probably about 30 or 40 big banks that are part of this consortium and using it. But again, talked to a bank in the largest trade finance bank in Peru just recently, and they're part of this, part of a membership, and they're really not doing too much of it yet. But again, it's laying the foundation for the future. Another one out there which has got a lot of banks contributing to it, TradeX. Their platform is Marco Polo, and they have actual relationship with R3 as well. How many people here are familiar with TradeX? Well, you don't count because you're an expert. But it's interesting because it's these are consortiums putting together lots of money with major corporations, major banks in progressing the blockchain technology, and it's just interesting how much it is known outside of the area of trade finance. Now this one's kind of interesting because Comgo is a new one. Just I don't have any connections to this at all. None of my customers are using it, but it does have a lot of potential because it specializes particularly in energy. And so what we're seeing is consortiums putting together blockchains around a specialty area, in this case energy companies that are trading commodities. Then this other one here, Cripsy, out of the UAE area. Again, now this is regional based, right? So there's going to be so many different types of blockchains by region, by industry segment. But I think one of the opportunities is to actually integrate those. So my business, TradeSun, top right-hand corner, is a trade finance platform, and we really provide the intelligence to get the unstructured data into a structured format. So to give you an example, documentary credit, trading documents, bills of ladings, shipping manifests. These are documents which have to be exactly interpreted for the issuing bank to be able to make payment to the exporter. And so to give you an idea, there's about 40 million letters of credit, which is the key part of this, 40 million letters of credit a year with an average transaction size of $680,000 per letter of credit. And so it amounts to about $13 trillion a year of international trade. And this is a very age-old process and a very long-winded process of executing cross-border trade. It's been going on for centuries, frankly, ever since ships sailed. And it's a way where an exporter, when they got their goods, they could be in Yemen. As they ship their goods, they want to get payment, and the banks will guarantee the payment to the exporter. So as they put their goods on the ship, they can get the money back, and they don't have that cash flow problem. But then the bank's on the hook to make sure when the ship gets to, say, Vietnam, that the beneficiary bank has to then take over to verify that the documents are all correct. And a letter of credit may have 6 to 8 different documents which has to match each term exactly. And so when you look at what blockchain can do here, it's got several things, 3 things in main, but the banks are providing. The banks are providing this checking of the documents. They're guaranteeing that the documents are correct, and they're providing the financing. And so the trust aspect of checking the documents is an expense, a large expense that the banks make a lot of money for. The exporters pay a lot for that to get paid ahead of the goods being received. And so this is how this process works. And to put that on a blockchain is fantastic, right? Because the time between any discrepancy in a letter of credit term and, say, a certificate of origin or a shipping manifest can take 5 days through this age-old, century-old system to correct. And time is money, because the bank's out the money. And so with blockchain, you will be able to do this within a day, not 5 days, maybe within the hour, right? Because if you've got all the different players on this consortium, then things can be accelerated. Now, even with that, you still have a problem of getting the data from a shipping manifest into a digital format. And part of that is, right, you can scan it in, you can OCR a document, and optical character recognition can look at the document and extract the data. But you still have to be able to understand what the data is. So if there's a shipper's name, you need to know that the data after that is the shipper's name, not just text. And so the interpretation of all the language on these trading documents has to be reconciled with a master contract, the letter of credit. So what we do is we're an adjudicator of third-party contracts, being able to replace the knowledge worker that's reading these contracts and basically reading all the information and typing it into a transactional system so it can be put in like a spreadsheet form. That is, to give you an idea, the largest trade finance bank in the world, HSBC, which is partnered with IBM on the Hyperledger fabric. They have 4,000, they call them makers and checkers. These are trade finance officers that every day they'll maybe do 6 trades a day. They get the documents and they match them and then enter in the amounts to be settled. And so it's a heavily manual process. And so that's what we do is take the analog world of people looking at the documents, understanding them, matching them, and typing in the results. And so for me, whether a blockchain consortium gets traction and standardizes the marketplace in the next few years, or it could be a dozen years, this process is still needed. I'll give you a little bit more example. So, because this is a very strange industry, but I think it's very appropriate. But it's one of a few holdouts in the digital revolution in banking, right? Banking has been on the forefront of technology. ATMs were decades ago, right? But this particular area of trade finance is still all manual. HSBC has 4,000 people. One of our clients, Standard Chartered Bank, has 2,000 people every day typing in this data. So this is a way to automate it. And it's a critical piece to get the data into a digital format that can be adjudicated. So in our system here, we have a list of trades, our application. So these are trades coming in, and the trade finance officer will pick off a new one and work with that. And so the documents coming in could be of various types: an invoice, bill of lading, certificate of origin, a packing list. So what the system does is it uses a classifier. It uses actual facial recognition to look at the document, which has been scanned in, may have been printed off an old dot matrix printer on a ship, all different various quality. It's able to look at it and figure out, oh, that's an invoice, no, that's a bill of lading, and classify it, because they're all coming in the stack, right? To classify it first, then after it's classified, it knows what type of trading document it is. It can then start to automatically extract data from there. And believe me, this is not very easy. It takes a lot of various types of artificial intelligence to be able to not only identify the respective data on a page, but know what it means. And a lot of times the English, and it can be different languages, but this is in English, you can describe things very different ways. So you can't necessarily look for something specific. You've got to read what's there and figure out the concept from the document. So this enables, this application, it enables a maker and checker to see the extraction from the document into a structured form. And then it'll also look for compliance issues. So one of the problems is shipping goods to countries that are on the sanctions list, or making payments to individuals which are on the, say, political exposure, PEPs, what does it stand for? Political exposed people. right? So there's dictionaries out there with all of these things to check. And what the system does, once you have all the data on the platform, you can do a really good job of checking against all of these libraries and dictionaries to make sure the trade is authentic and it's not going to have any compliance issues. And then finally, this is what's interesting is you have all the terms, all the particular terms from a letter of credit. And then what this does is match the terms from the respective trade documents, the invoice, the packing list, all coming from different places typically. And then if it sees the algorithm, the AI algorithm, if it is unsure, like here, it will flag it as a review needed. So in this case, it's probably hard to see on the screen there unless you've got good eyes. But basically, on the certificate of origin, it's saying the issuer is the Shanghai Chamber of Commerce and Industry. But on the letter of credit, it said Chinese, the Chinese Chamber of Commerce and Industry. So not quite the same. And in some cases, the machines say, yes, that's good enough, we'll match that up. But this is a good example of where we will rely today on a human to be able to say, yeah, they're the same, or they're not. And so once the human has seen that, it can approve a document, and away it goes. So the goal of this is to actually automate the whole process, right? But it takes a while to change an old industry that's very, very manually based. And so when you look at it, what are the trends with how this fits into blockchain and whether it be public or private, on-chain, off-chain? And one of the areas that actually was on the hype chart from Gartner, which is accelerating more than blockchains in general, is blockchains for data security. And so in our application, this is something which may be of interest, is we're using blockchain in a slightly different way, and it's to authenticate the update of a knowledge graph. So when this system has been used, this artificial intelligence trading platform, a human can override or approve a discrepancy or say this address is wrong, but to update the model, and when this has been used by thousands of people, you need a mechanism to say, okay, we'll update our knowledge graph, or you could say dictionary, with this change. But you don't want to do that if it's not right? Because then someone else using it would then accept maybe a discrepancy which wasn't right. So what we do is we use a way for a broader set of people, a broader set of users to be able to approve that this is a change which everyone agrees to. We route the same document to multiple people and see if they're going to make the same change to it before we update the dictionary. So it's like a consensus base of knowledge, and the different levels of confidence we have, whether we want to update the knowledge graph, this is the brain of the AI, or not. Because once it's updated, we want to lock it in and make sure then no one else can update it unless the consensus of everybody using the system to a certain degree is validating that. So data security, I think, is a good prospect for that. And then to your point, Chris, the ledger without blockchain, right? And the biggest one out there, R3 the quarter from R3 is not a blockchain. Would you agree with that?
Let's talk about that offline.
Okay, very good, very good. And so one of as our company TradeSun, we see ourselves as a blockchain app, right? We kind of sit in the middle. We're an on-ramp to the blockchains, but we're also like an inter-blockchain, and that we will be the intermediary where we haven't got this yet, but we plan on being able to exchange transactions between blockchains.
Functioning as an oracle, right? As an oracle.
Oracle, the database?
Yeah, well, no, as an oracle, translating the real world to the trusted blockchain world.
Yeah, that's a good word. Yeah, that's a good concept for that. I was just a little confused with Oracle with database. Yeah. So anyway, this is the last slide that one of my colleagues put in for me. We're finding use cases, and the technology is changing as we go, right? So with the froth settling, we are bullish overall on the prospects of blockchain. So I'll wrap it up at that.